Whether a given acid will lose a proton in an aqueous solution is going to depend on both the pK of the compound and also the pH of the solution. There is an important relationship between pK and pH, which has been given by Henderson-Hasselbalch equation. And here is the Henderson-Hasselbalch equation. And this Henderson-Hasselbalch equation is a very useful equation because it tells us whether a compound will exist in its acidic form or in its basic form at a particular pH. Because knowing this will be very important when we are assessing the reactivity of the organic compounds. Let's take a scenario here where the pK of the compound is 5.2. Now, according to HH equation, when the pH of the solution is equivalent to the pK of the compound that is undergoing dissociation, then the concentration of the compound in its acidic form and in its basic form is going to be equal. Now, if the pH of the solution is lesser than the pK of the compound, let's say that the pH of the solution is 3.2, then in that case, the compound is going to exist in the acidic form. And if you increase the pH, which means, let's say that you're going to increase the pH to 7.2, in that case, the compound is going to exist in the basic form. In other words, we can say that the compounds are going to exist in their acidic form in solutions that are more acidic than their pK values. And they are going to exist in the basic form in solutions that are more basic than their pK values. The HH equation can be very useful in the laboratory for separating compounds in a mixture. Water and diethyl ether are barely soluble in each other, or in other words, they are immiscible, and you can definitely see two different layers. The water is going to stay at the bottom and the ether is going to stay at the top because it is less dense than water. In general, the charged compounds will be more soluble in water than in ether, whereas uncharged compounds will be more soluble in diethyl ether. So water is going to take the charged compounds and diethyl ether is going to take the uncharged compounds. Let us say that we want to separate carboxylic acid from protonated amine. How are we going to do this? How are we going to separate these two compounds from each other? We know that the pKa value of carboxylic acid is about 5 and the pKa value of protonated amine is 10. Now, if you adjust the pH of the solution in such a way that it is lesser than the pKa value of this carboxylic acid, okay, then this carboxylic acid is going to be existing in the acidic form, and this acidic form is uncharged. And because it is uncharged, it's going to go get extracted in the diethyl ether layer. Now, because the pH of the solution is lesser than the pK value of the compound, the protonated amine is also going to be in the acidic form, but the acidic form is charged, and therefore it is going to go get extracted in the water layer. Finally, you can separate the diethyl ether from water using a separatory funnel, and you can separate the two compounds, carboxylic acid and protonated amine.